Good afternoon. In this video, we are going to talk about proposition 29 from book 1. So this proposition declares that if we are given two straight lines, parallel straight lines, and another straight line, cut them, and then we have the exterior angle is equal to the opposite interior angle, and the sum of two interior angles from the same side will be equal to two right angles, and the alternate angles will be equal. So, for example, we are given that L1 is parallel to L2, right? And we can conclude three results. The first one is that the alternate angles are equal. So alpha will be equal to gamma. And the second scenario is that the exterior angle will be equal to the opposite interior angle, right? So theta will be equal to alpha. And the third case is that the sum of two interior angles from the same side will be equal to two right angles. So the sum of them will be equal to two right angles. Let's try to prove them one by one. So we are going to apply the method of contradiction again. So please recall how to use it. The first step is to make a hypothesis. The proposition states that alpha is equal to gamma. So let's hypothesize alpha is not equal to gamma. Sorry, not equal to gamma. And for convenience, let's just suppose alpha is less than gamma, right? And let's see what we can derive from this hypothesis. So at first, please recall proposition 15. If two straight lines meet with each other, then the sum of two adjacent angles will be equal to two right angles. So we see that L and L2 are meeting with each other. So we know that the adjacent angles, the sum of them will be equal to two right angles, right? And we know that alpha is less than gamma, right? And if we combine them together, this is our hypothesis. So if we combine them together, we know that alpha plus beta will be less than two right angles, correct? And please recall postulate 5. If a straight line cuts the other two straight lines, and then the two interior angles from the same side, if the sum of them is less than two straight angles, then these two straight lines will meet with each other in this side. So it means these two straight lines are not parallel, okay? So which means L1 is not parallel to L2, which absolutely breaks our condition. So they are contradictory to each other. So our hypothesis is false, which means alpha is equal to gamma exactly, right? So we proved our first statement. And then let's try to prove the second one. In this statement, please at first recall proposition 13. It says the vertical angles will be equal. So let's see, L1 and L2, they are meeting at this point, and they are vertical angles. So we have theta equals to gamma, right? And we have already proved that alpha is equal to gamma, right? Alpha equal to gamma. So if we combine them together and apply common notion 1, things equal to the same are equal. So we know that alpha is equal to theta. And we proved our second statement. And then let's try to the third one. So the third one will be alpha plus beta is equal to, okay. So we have already prove that alpha is equal to theta in proposition 2, and then we can apply common notion 2. It says if we add the same thing to two equal things, the results are same, right? Oh, sorry. Should be forget the arrow. And so let us add beta to both sides of this equality. Then we know alpha plus beta will be equal to theta plus beta, right? And what is the theta plus beta? Let's use proposition 15 again. So the adjacent angles, the sum of them will be equal to two right angles, right? So we have theta plus beta will be equal to two right angles, okay? And then combine them together and apply common notion 1 again. We know that they are the same, so they are equal. So alpha plus beta will be equal to two right angles, which proves our statement. And if we combine scenario 1, 2, 3 together, we can say we have successfully proved our proposition 29. And I'd like to add a piece of additional information. So it is called converse statement, okay? So if we have the original statement like if P then Q, the converse statement will be if Q then P. We just switch the position of P and Q. So if you can remember proposition 27 and 28 from book 1, they are declaring that if we are given this kind of conditions, then we can conclude these two straight lines are parallel. And proposition 29 says that if we know that these two lines are parallel, then we can conclude the relationship of these angles. So to be honest, we can say that 27 and 29 together, they are the converse statement of 29, or vice versa. So if we say this is P, this is Q, and they are saying that P, if P then Q, and 29 says that if Q then P, okay? That is so-called converse statement. I think this is the end of this video, and in the next one we are going to talk about proposition 30 from book 1. Thanks for watching. Have a good day.